Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will learn more about LNG network modeling using gap software. And now we are at the point where we will define the pipelines. However, as I said before, I will use the model that's already, prepared, including the dimension of the pipeline. So rather than populating data into each of this pipeline, I will just show you what is, how the pipeline looks like. All right. Okay, so let's check them one by one. Okay, first, as I said before in previous topic about oil network modeling, the connection between reservoir and the well, is not pipeline. Okay, so if you double click on this connection, you will be directed into the well input screen. Okay, so it's not the pipeline. It's not pipeline. Okay, I mean, use this. Also this, it's the, the pipeline input screen. Okay, and then the connection between the well and junction, if we double click, you cannot enter this. It's not pipeline. Okay, the connection between well and junction, this point, the junction, it's not a pipeline. So the junction is here, or joint, I mean. However, the connection between one joint with another joint will form a pipeline. So if we double click on this, I'm entering my pipeline. Okay, so we are in pipe input screen. This is the summary. Okay, pipe type, gap internal correlation I used, and then correlation petroleum experts 5, gravity and friction coefficient of 1. And then for the input, here the surrounding temperature of 50 degrees Fahrenheit. And then the description, this is the dimension. So for this pipeline connecting wellhead 1 with the manifold, the length is 3 kilometers. Okay, and then horizontal pipeline with inside diameter of 6 inches. And this is the roughness. The upstream is the wellhead 1, and the downstream side is the manifold. And rate multiplier 1 with maximum length step of 10,000 feet, and then flow type tubing flow. So it's not an annular flow. And then matching still blank, constraint still blank, also the schedule. Okay, so that's the pipeline, this one, and then the same thing with pipeline 2. So the length 4 kilometers, horizontal 6 inches, inside diameter. Okay, so if I say I will define the pipeline, basically what I mean is populating this summary screen and input screen with data, the dimension of the pipeline, the main thing. All right, as the main thing. Okay, and then the connection between one joint, the manifold, and the top joint also form the pipeline. Okay, so if we go back at the summary, the same. Input, the same, surrounding temperature. And the description, the length will be 5 kilometers, inside diameter 10 inches. So it's a bigger pipe. Okay, and then connection between this, the top joint and the separator, it's not a pipeline. Connection between separator and this, this condensate line, gas line, and water line. Okay, it's not a pipeline. Okay, so here it's actually source or sink like this. If source, then it will be like this. If sink, then it will be like that. Okay, so delete. Okay. And then later, I will show you what this source is. And the connection between source I mean, and this join 2 or join 1, also not pipeline. And the connection between join 1 and join 2, J2 or J1 to LNG plant or to the water separator here, also not pipeline. Okay, it's just, it's only source, so you cannot actually connect this with pipeline. Okay, so it's basically from separator go directly to the LNG plant. Okay, like this. Okay, so if we think about it, then you can think that this well, it will be directed or it will be connected to pipeline, of course, pipeline to the manifold. Okay, you can think about it in your mind. And then from manifold to the separator, you will have pipeline. And then from the separator, okay, we stop at this separator actually. So connecting the separator to LNG plant, basically we do not need to define any pipeline. Okay, but can we connect separator like this? Let's just test it. Production separator and another separator, which is in this case LNG process plant. Just, for illustration. And then can we connect? You cannot actually. Okay. So you cannot connect separator to LNG plant. That's very important. But let's say I have joined here. Let's just test it. Connect the separator to joint. Okay. You cannot enter it because it's not pipeline. And connect joint to LNG process plant. Okay, you cannot actually, you cannot do it. Okay. It's just for illustration, so it's like this. The separator or the LNG process plant will be, will be the downstream side. But of course, you can connect this joint and that joint and it will form pipeline. Okay, that's for illustration actually. I'm going to delete it. So I talk about that basically to help you understand what happens downstream of the separator. Okay, so that's about it. We have, defined the pipeline. And then what else? If we go to the pipeline, for example, this, okay, and then you can validate data is okay. You go to the environment to check and then description. So please notice that we have heat transfer coefficient here. Why? First, I'm going to cancel it. If we go to options, method, don't forget we have temperature model, improved approximation. Okay, this is important. In the improved approximation method, we have, the option to define a heat transfer coefficient for each segment of pipe. That's why you have heat transfer coefficient here of 3 BTU per hour per square foot per degrees Fahrenheit. If the heat transfer coefficient varies along the pipe length, then this can be captured by adding multiple pipe segments within the pipe description. Okay, so for example, like this, I can assume that throughout this pipeline, with the distance of 3 kilometers, the heat transfer coefficient will be the same. It will not vary along the pipe length. Then I can use this pipeline with only one heat transfer coefficient. But if I know that the heat transfer coefficient will vary along my pipeline, then I can just, make this pipeline to be multiple segment of pipe rather than just one pipeline, one segment of pipe. Okay? And to keep it simple, we can assume that the pipelines are horizontal. So the TVD from upstream to downstream will be 0. Okay, so that's about defining the pipelines. So we can stop it here. In the next video, we are going to set the well controls. Okay, until then, thank you.